Have you already got it set up where it's live? Where we can just do
Yeah,
questions on?
it's already pulled up. It's going to be recording, or it's already recording. So
Okay.
once we can just exit out of it.
Can you guys hear me?
Yeah.
Okay, sweet.
Yeah, we can hear you.
Okay. Let me pull up the stuff that they're doing. So I can only be on here for 20, maybe at the most 30 minutes. But I think it shouldn't take us that long.
Okay.
Okay. And then because he's getting up on the computer soon.
Okay.
So.
Should we go ahead and get started?
I think we're fine. Is someone YouTube broadcasting this?
Yeah.
Yeah, I am.
Okay, sweet.
So I'll just upload it when I'm done.
Okay, did you guys open it up yet?
Yeah, I've got mine open.
Yeah, I have
Okay,
mine too.
Yeah, I might open too.
So 1 and 2 are pretty easy. I don't think we need to. Did you guys have any questions on the homework?
I didn't.
So are we good to start on the quiz?
Yeah, I think we're okay to do that. Hopefully,
Yeah.
Phil can get up and he can get this, but yeah.
So we're starting question 3, right?
Yeah.
Yeah.
Isn't that true? Number 3, would that be true though?
The types and portions given in the table above define a probability distribution.
That's what I put down. I think it's true.
I think it's true too. What is the probability that randomly selected person units that has type O blood? So do we just take type O blood and let's see. Oh, my calculator with me right now. Are you guys doing calculations on there right now?
What was that?
For number 4. So we have to find. Let's see. So would we just, let's see. What I'm thinking is
Isn't that already a probability?
It is. That's what I'm saying. It's already at a percentage, but the portion of people in the population.
Hello?
How's it going?
Good. How are you guys doing?
Good.
Apologize for being late.
It's okay.
Did you guys just start it?
Yeah, we did.
Yeah.
We're just on question 4 right now.
Okay.
Got true for number 3.
Okay.
So guys, that sounds about right what you're saying, Thomas, but it just seems too easy.
Yeah.
I think though that it's the questions that they're asking. This kind of falls into where we have the third rule, like the third and second rule of probability, where it all has to equal 1. because the next question is asking what's the probability that a randomly selected person will not have type O blood. And I feel like that's when you subtract 0.45 from 1 and you get 0.55. But if that's not the case, then I don't really know how to get to the probability because they didn't give us that.
You wouldn't add them up and then divide. That doesn't make sense.
Yeah, we just don't have any data to add up the division.
Is it all supposed to equal 1 though altogether or no?
Yeah, if you add it all up, it does equal 1.
Yeah, that makes sense what you're saying. So we just put 0.5 and 0.55. That makes the most sense to me. Do you guys agree on that, or what do you guys think?
Yeah, I think that's the right idea.
Mm-hmm.
You say 0.55?
Yeah.
Okay.
That's what I think.
That makes the most sense because I'm trying to look for other data to see if we can use, and there's nothing else there except for that table.
Yeah.
Okay.
Okay.
I'll read the next one. Carolyn Wells and her colleagues conducted a study in which dogs were trained to detect bladder cancer. Dogs were trained to lie down next to a specimen derived from a bladder cancer patient. Tangle, one of the dogs demonstrated identification of a specimen, 7 bowls containing urine were lined up in random order. 6 of the samples were from patients who did not have bladder cancer. One of the samples came from a person identifying it as a bladder patient. Did the dog guess at random? What is the probability that they will correctly identify the dish containing the specimen from the bladder patient? So it's going to be like 1 out of 6, right? Because there's 6. So it'd be,
No, it'd be 1 out of 7.
or is there 7?
Yeah, because 6 of the samples are from patients who don't have cancer, and 1 is.
Oh, yeah. Yeah, I get what you're saying.
Cancer.
Sorry.
Yeah.
So that'll do 0.143 if it's 1 out of 7.
That's
For
what I got
decimal.
on it.
Yeah, my bad. I forgot that there was another one.
0.14?
It says
143.
the answer to the 3 decimal places.
Oh, 0.142? Oh, 143? Okay.
Yeah.
Yeah.
Okay. I hate rounding. Okay. Combined total. I'll read the number 7 then.
Okay.
In a combined total of 54 trials, the dogs correctly identified the specimen from the cancer patient 22 times. It is very unlikely that the dog would do this well by random chance alone. Which of the following statement is most appropriate?
I did the calculations, and it comes out to like 41%
Mm-hmm.
success rate on there. That's like their probability from that. I think that provides strong evidence that the dogs can detect bladder cancer.
Yeah.
Yeah, 40%, 41%. That's pretty strong.
Okay. Was there any rule? Nah, maybe that's just in science, so they have that one rule, but it's not in this class. It's like the rule of 95%, but I think that's right for what we're talking about here,
Mm,
because that's not what we're learning about.
yeah. Okay, M&Ms are small chocolate candies. The M&Ms website previously indicated that in the United States, the distribution of the colors in a bag of plain M&Ms is given in the following table. Brown is 0.13, yellow is 0.14, red is 0.13, blue is 0.24, and orange is 0.20. If you reach into a bag of plain M&Ms, what is the probability of drawing a red-colored candy?
Why did it black out green?
I think it might be because they got rid of green. Maybe.
So it's
So I got 0.16 for green. I added up all of the brown, yellow, red, blue, and orange, and
Oh, yeah.
green would be 0.16.
Gotcha.
Green is 0.16?
Yeah,
Oh, because you added all of them to equal 1, is that why?
yeah.
But we're trying to find red, right?
Yeah, but that, I don't know, maybe that might help us later on.
Yeah.
Can you
So
hear
is
me
it-
now?
Yeah, we
Okay.
can hear.
Oh, yeah. The next question that's asked. So I think it's 0.13 for red.
Of course, because it's on there, yeah.
Yeah.
And then the
And
green
the
is
next
going to
question's
be 0.16.
Because all of them added together, if you take it away from 1, green is 0.16, right? That leaves you
Yeah.
0.16 left, right?
Are we
And
on
then-
10? What question are we on?
10.
Okay.
Wait, so
I
number
got,
eight. So number 8 is 0.13.
yeah,
Okay.
that's what I think.
Okay, and then
Number 9, we got 0.16.
yeah,
Yep.
I
And
agree.
Then I would think 0.84.
0.84, yeah.
Yeah,
Yeah. You're subtracting 0.16 from 1.
Okay. So we're on number 11.
yeah,
Have you guys already read it?
not yet.
Okay. The ACT scores of students admitted to a medium-sized public university in the Western United States were taken from Capix.com. The following summary statistics were calculated. Half of the observations are less than or equal to what number?
Half of them are equal to 1 number.
Would that be the median? Because the median is 24.
Median, because it's like the most, or it's the middle number. Usually
Mhm.
it's the top of the distribution curve, right?
What?
Is the median, or is that the? I said the median's usually the top of the distribution curve, right?
Yeah, it's usually the median and then the mean is just slightly lower.
Mm.
So that would be.
Because the mean is the average, and the median is the middle number that's been chosen.
hmm
So it's 24.
What do you guys think?
I think that's going to be our best guess, yeah.
So this is asking for what is like a 50 percentile, right?
Yeah,
Yeah, I agree. The median will be more closer to the
So
middle.
that would be right in the middle. Would be the 50. Based on the information on the top 25% of the students scored above what number? So that would be
27.
25%.
Not 27.
Why? Because that's the third quartile.
Yeah.
Wait,
Yeah.
Yeah.
35 is the max, and the third quartile is the four-way. Yeah.
Third quartile is the 75th percentile.
Okay, so that's gonna be the 27, right?
That's what I think
But
it
it's-
is.
Yeah. Because it's asking who scored above that. So
Yeah.
that makes, because if it's the 75th percentile, then that's the top 25% is after 27. I don't know. Does that make sense to you guys?
Yeah.
So yeah, would we minus 35, which is the maximum, minus 27, and we'll get the number? Or does that make sense?
35 minus, you said what?
So I don't know. I'm just kind of throwing out numbers, but like the maximum is 35, so that's the highest. And we want the 25% who scored higher than a 75%. So will we minus 35 minus 27? And we'll get a number there that will be the 25% who scored that much.
I think it's more asking that the best students, the top 25 students, what would they have had to score to be in the top 25%? Because if you're in the 75th percentile and the maximum 35, if you're past the 75th percentile, then you're in the 25%. So they had to have scored higher than a 27.
Yeah.
27 to 35.
Yeah, I agree with that.
Me too.
That makes sense. We'll check it after this anyways too. So
27 is our guess.
Yeah, that's what I'm guessing too. Okay.
So 13.
Now we're on 13. Which of the following statements is not one of the three rules of probability? The probability that an outcome will occur is 1 minus the probability that it will occur. Probability is a number between 0 and 1. The probability is high when probability is positive. If the probability is low, then the probability is negative. The sum of the probabilities in any probability is 1. So which one of these? Let's see. I'm trying to remember the rules right now.
Would it be if the probability is high, then the probability is positive?
Yeah, because there aren't any negatives in the probability.
Yeah. I agree.
I think that's all of it, isn't it?
Yep.
Should be.
Okay, I'll go ahead and submit it.
Okay.
Oh, you're taking off with them? Where you going? Oh, you're not going to.
We got 100%.
Wait, are you going?
So
Yeah, we didn't miss anything.
yay.
That was the quiz.
So on number 4, what'd you guys get?
We got 0.45.
4 or 5, okay. And the 5 is 0.55, right?
Yeah.
Okay. All right.
So, does that conclude it then?
Yep.
Yeah, you guys want to just meet at 6 on Wednesday?
Sure.
Yeah, that works.
Let me see, because I might have to work in the temple that night. Or it's tomorrow that I work. I'll text you guys though, but just plan on it for right now.
Okay.
Yeah.
We'll plan on 6 on Wednesday, okay?
Yeah, 6 on Wednesday. I'll make sure I send out the text, and everyone just respond if you can make it or not. Anything last minute, okay?
Okay.
Okay.
Sounds good.
Hey, thanks guys.
Thank
Bye.
you.
See you guys.
Bye.